This question is from GATE 2015 Mechanical Engineering Paper Set 1, question number 41. A pinion with radius R1 and inertia I1 is driving a gear with radius R2 and inertia I2. Torque tau 1 is applied on pinion. The following are free body diagrams of pinion and gear showing important forces F1 and F2 of interaction. Which of the following relations hold true? We have to find out the relation between forces, the value of torque tau and the value of force F2. Let's find it out. Our aim is to find out forces and torque. So definitely we will use the static equilibrium equation and the dynamic equilibrium equation. As per the figure, we know that this point of contact for pinion and gear, although they are two different points now, but when they are in contact, it's a single point. At the single point, the forces will be balanced. So net force at contact point should be 0, and therefore F1, which is upward, minus F2, which is downward, is equal to 0. And this gives us forces F1 and F2 are equal to each other. Also, this one single contact point cannot have two different velocities, and therefore for contact point, velocity of gear will be equal to velocity of pinion. And this I am talking about the tangential or the linear velocity, not the angular velocity. That will definitely be different for both. As per the definition of linear velocity, we can write it as product of angular velocity and radius. So for gear it will be subscript 2. So omega 2 into R2 will be equal to, for pinion it's subscript 1. So omega 1 into R1. Omega 2 can be written as theta 2 by T R2, and omega 1 can be written as theta 1 by T and into R1. So the time that is taken for the revolution is same for both of them. Therefore, it will be equal to each other. So we can cancel it out from both sides. So we have the relationship theta 2 R2 is equal to theta 1 R1. Let this be 1 and this be 2. We are going to use these two equations further. Now, the body is rotating. We will have to take into account the Newton's second law of motion for rotating body. And therefore, so we can write summation of all external torques on the body should be equal to moment of inertia of the body into its angular acceleration alpha. For linear translating motion, we have summation of all external forces is equal to mass of the body into linear acceleration. But for a rotating body, the external forces are taken as torques and the internal inertia is taken as moment of inertia into angular acceleration. So this can be applied for both these free bodies, pinion and gear. First one, for pinion, we have tau 1 is the one external torque and it is clockwise. Let's take it positive tau 1. And the other torque that is applied to it is F1, this contact force F1 into its radius R1, because we are taking about the center of pinion. So tau 1 minus F1 R1 is equal to moment of inertia of the pinion I into angular acceleration. So rotation is theta 1. Angular acceleration will be double derivative of theta 1, which is theta 1 double dot. Second, for gear we will have, as tau 1 is applied to pinion, there is no external torque in case of gear. But F2 into R2 will be one external torque that is being applied here. So we can write F2 R2 will be equal to I2 theta 2 double dot. Here also for pinion I'll use I1 as the subscript for moment of inertia. So I1 is moment of inertia of pinion and I2 is for gear. Now let's substitute the values further and find out tau 1. Let me also write equations 1 and 2 here. So F1 is equal to F2 and theta 2 R2 is equal to theta 1 R1. Now we take tau 1 is equal to I1 theta 1 double dot plus F1 R1. And F2 will be equal to I2 theta 2 double dot by R2, which is equal to F1. We have it from equation 1. Second thing, theta 2 is equal to theta 1 R1 by R2. So if we differentiate this twice with respect to time, we will have theta 2 double dot will be equal to theta 1 double dot R1 by R2. Therefore, when we put theta 2 double dot here, we will have F1 equal to I2 theta 1 double dot R1 by R2 upon R2. So it is R1 by R2 square. This value of F1 will put here in the expression of tau 1. So we'll have I1 theta 1 double dot plus F1 is I2 theta 1 double dot R1 into this ratio. So it is R1 square by R2 square. R1 by R2 whole square. This is the value we get for tau. F1 is equal to F2 from equation 1 we got. And we get the value of F2 here. So let's go back and mark the option which has all these values. This one, this tau 1 and F2. We see the correct option here which has all those values. It's option B. Option B is the correct. To learn more about gears, you can refer to the NPTEL video, Lecture 3, Laws of Gearing, Kinematics and Geometry Part 2 from the course Gear and Gear Unit Design, Theory and Practice. This course is by Professor Athindranath Methi. He is from Department of Mechanical Engineering of IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.